Hello guys, today we will see the lead code problem number 2975, which is maximum square area by removing the fences from a field. Okay, so it is so let's see what the question says. There is a large m minus 1 into n minus of 1 rectangular field with the corners 1 by 1 and m by n. Okay, containing some horizontal and vertical fences given in arrays H fences and vertical fences V fences respectively. Horizontal fences are from the coordinates H fence of I of 1 means yes H fence of I to n. Okay, so these are the horizontal fences which are present there, and the vertical fences which are present there by from this one vertical fences to m V fences of I. Return the maximum area of the square field that can be formed by removing some fences, possibly none or minus 1 if it is impossible to make a square field. Okay, since the answer may be large, return it modulo 10 to the power 9 plus 7. Okay, note the field is surrounded by two horizontal fences from the coordinates this to this and two vertical fences from the coordinates this to this and this to this fences cannot be removed. Okay, so 1 to n and the n means the boundary fences cannot be removed. Okay, so these are the boundary fences which cannot be removed at all. Okay, in this way it has given to us that we can remove any of the fences, but here it is given that we can remove this fences. Okay, so now it has given to us that how many fences we can remove. Okay, so firstly we will have to figure it out that how many fences we can remove and how many fences are still be there. So now in this question it has given all the vertical fences which we can remove and the horizontal fences which we can remove. Okay, and m denotes all the horizontal fences, the number of horizontal fences, and n denotes the number of vertical fences. Okay, so here 6 is there m, so there can be 6, but only 2 is present which we can remove and only 4 is present as a vertical fence which we can remove. All the other fences are not present there. Okay, so 2 3 are not present here and 5 and 6 also are not present in the vertical fences. Okay, so vertical fences only denotes that which we can remove as a vertical fence. Let's see in this example. Okay, we will make our own examples. Okay, just take the screen. Okay, in this way we have our square grid and all the fences we have. Okay, now in this way we have our square grid, but now it cannot be possible that one. Okay, now let's take 1 2, here 3 is present, 4 5. Okay, so 3 horizontal 3 fence. Okay, the third number of fence is not present there. Okay, at all. 1 2 3 4 5 and 6. Here 5 number fence is not present there. So now how we will figure it out that how many the empty space we will found by removing any of number of the fences. Okay, so to approach this question we can think that if we can delete all the fences. Okay, if we can delete all the fences means if we have deleted this one, okay, also we have deleted this one. Okay, so can we form any of the region which will form the square grid? Okay, it has given us it can be a square only, maximum area of square field. It cannot be the rectangle. Okay, So only square field we will need. So after removing this 2 and 3 and 4 also, we will get this whole area, okay, whole area which contains 5, okay, 3 and 2, 5 by 5 by 5, but horizontals are present there, okay, horizontals are present. So 5 by 1 we can get, 5 by 2 we can get by using this 5 by 2, 5 by 1, 5 by 1, okay. So 5 by 2 is the maximum one we will get, but it cannot be the square, okay, it cannot be the square, so we cannot get this, okay. So we only need the square. To get this square, we will have to get that the number of continuous or the number of blank space between this and this, or this and this. So the number of blank space after deleting the 2 and 3, means between 4 and 1, after deleting all the vertical fences between 4 and 1, okay, after deleting them we will get the area of 3, okay, we will get the area of 3, sorry, not the area, we will get the length of 3, okay. Then we have to find that only 3, means after only 3 fences, only 2 only 3 breadth. Now we have got, after deleting 2 and 3, we have got 3 as our length. Now we will need breadth as also 3, okay, we will have to find out now we will have to find out the 3 breadth from this by deleting the horizontal fences. So by deleting the 4th fence, okay, we can get to know that this 1, 2 and 3, this 3 can be the breadth for us, and after deleting this we can get to know this much of the area as our answer area, okay, which will be the maximum area, maximum square area we can get, okay. Now to get this answer as a length and breadth, we will have to find out that how many all the possibilities are there, means if we delete this to this, if we delete this to this, this to this, this to this, this to this, and for all of them, okay, after getting this to this, then we will go for this to this, this to this, okay, sorry, this to this. So are you figuring out the what I am wanted to say, that we will go we will apply the n square loop, okay, so double for loop we will apply, nested for loop, from here to here we will figure out the distance from here to here, we will figure out the distance from here to here, we will then figure out the distance from here to here, but now we will not count the 5th one, okay, because 5th one cannot be the boundary because it is not present at all, okay, the fifth fence is not present at all, that's why it cannot be a boundary when we are calculating distance from 4 to 1. So the 4 can be the boundary, and all the fences which are present between 4 and 1 will be deleted, means 2 and 3 is also deleted, okay. If there is any case that 3 is not present there, so again the 4 to 1 will be validated because 3 is not present at all, so we will not have to make it as a boundary fence. The boundary fence will be only 4 and 1, okay, for the horizontal for the vertical boundaries, okay, we are talking about the vertical boundaries. So only 4 and 1 will be the vertical boundaries fences, and all the fences which are between 4 and 1 we have to remove them. So that's why we will have to find out the difference between we will have to find out that how many of them we can remove from this to this to this. We will not count for the 5 fifth, we will count for the 6th. And if there is not present, if 3 is not present here, so we will not count 3 also. Okay, after getting this we will count from 2 to 3, 2 to 4, 2 to 5, 2 to 6, okay, 2 to 5 we will not count. Okay, now we have not count the 1 also, 1, because 1 to 2 we have count already. Okay, in for 1 we have count already. So that's why in this way we will count that how many length we can get. Okay, by getting all the combinations, how many length we can get. Okay, after getting this we have to figure it out for similarly for this to this to this. Okay, so the 3 is not present, so we will not count from 1 to 3, we will count from 1 to 4, 1 to 5. Okay, and similarly for 2 to 4, because 2 to 3 will not be counted, then 2 to 5, then again for 4 to 5. Okay, so in this way we will calculate all the possibilities from the horizontal and from vertical also. From vertical and horizontal we will count all of them. And now after counting this we will figure it out for forming square. Okay, for forming the square we will initially count this, or initially find this. Okay, we can do any of them. Now finding out them, we will store it in the set. Okay, we will store in the set, or we can say we can store it in the map also. Okay, then after this we will need a square, because length and breadth, length should be equal to the breadth in the square. So that's why we will need this. We will need the number of verticals is equal to the number of horizontals we will delete it. Okay, so empty number of verticals and empty number of horizontals should be similar. So that's why when we will count in the set, so we will let's see we have counted firstly for the verticals. Okay, then we will store them into the set, and then we are counting it for the horizontals. Okay, so when we are counting for the horizontals, so we will find it out if they are present in the set. Okay, so if they are present in the set, so means we will get to know the length is equal to breadth, length equal to breadth. So that's why we can change our answer as length into breadth, which is the empty space which can be formed there. Okay, so this is our overall solution by which, and our answer should be maximized. So at each time when we got that particular empty space in our set, so we can update our answer as maximum from answer into L into B. Okay, so because we will need the maximum answer, it is given that return the maximum area of square field, so that's why we will get the maximum of them. Let's see the code. Okay, and again it is given that we have to take the modulo for the answer, because answer can be very large. So that's why we have taken that constant is equal to mod 1 in 9 plus 7. Okay, so in the function we have declared unsorted set. If you are doing in C++ with the set only, not ordered set, okay, if you have used the ordered set, so you will get the TLE, because it can when the numbers are very big in the set, so it may take O of log n or O of n time also. So that's why the best practice is to use the unordered set. Okay, if you got the TLE, so you can use the unordered set. Otherwise you can use the set also. In many conditions set also gives the valid answer, but in some of the conditions unordered set may reduce the time complexity. Then we have H fence and H fence. Okay, so these are the boundary fences which we have added there. Okay, because only this. Okay, if we have given, okay, if the question is given this of the fence. Okay, this 1 2 3 4 2 3 4. Okay, so only 2 and 3 are mentioned in the horizontal vertical fences. Other than that 1 and 4 are not mentioned, so that's why we have mentioned this in the in our array. Okay, we have pushed back them into our array as a boundary fences. Okay, because they are our boundary. Okay, then after mentioning them, after push back them into our vertical fence and horizontal fence, we will sort them to figure it out that how much distance, how much empty space we can form for every horizontal fence and for every vertical fence here. Okay, so in the horizontal fence, we will store it out in our set, and after that when we are finding the all the empty space for vertical fence, so we will not store it in another set. Again we will do the number of time complexity we will exceed. Okay, so that's why we will directly now here find out that if that difference, if that empty space is present in the set 1 already, so our answer can be changed now. Okay, answer can be maximized. Okay, then after that answer is storing only the length or the breadth. Okay, so then answer will be storing the length into breadth. Okay, firstly we are storing only the length or the breadth, but then after that we will modify our answer and we will make it square. Okay, and after making it square we can take the modulo because it can be very large, so that's why we have taken the modulo, which is already mentioned in the question that to take the modulo for the answer. So that's our solution. If you are not getting any of the concept, you can comment down below and I will be clearing your doubts. Thank you.